Okay. Can you see my presentation?
Yes, we can see.
So, good morning to everyone. First, I would like to thank the journey organizer who have given me the opportunity to be here today and share my research work with all of you. I thank the host, the moderator, and the attendants too. And apologize not to be in the previous season as the secretary requested me, but I was a little bit busy. We are starting our classes and many students who don't know where they have to be. So the subject of my presentation is a specific study we did about gypsum composites containing cigarette butts for building applications, and more specifically in acoustic application, like an absorbent material. We are going to use these cigarette butts like an absorbent material. We know we know the construction sector is one of the industries responsible for the highest environmental impact, and it consumes great amount of natural resource and generates vast quantities of waste. The negative environment impact caused by the construction sector can be reduced by promoting waste recovery, as we are now doing. Many research works have been conducted aimed to characterize building materials containing several wasted categories from different industries of society. One of the largest wasted generated in our society are cigarette butts, which represents around 13% for total items collected in our seas. And approximately 6 billion cigarettes are smoked per year, and the butt of 3 out of 4 cigarettes is thrown out inequally. The problem is not only the large amount, is to collect them, because another waste is more easy to collect. Glass, we have a big container and we put plastics, glass in this container. But smokers smoke anywhere, and butts are very light, so they are easily spread for all our landscape. It's for this reason several researchers have explored the ability of incorporating cigarette butts in different composites for building construction. Most of these studies incorporate cigarette butts in concrete, bricks, or asphalt, because all of those are large industries. So in this case, we incorporate cigarette butts in gypsum, in plaster. In the other hand, cigarette butts is made by cellulose acetate. So we would like to take advantage of the material, because it's a fiber that can be an absorbent material. So we combine in this study these two things. We use them as an environmentally friendly additive and an additive that could improve acoustic performance. So we made samples in gypsum, containing gypsum, the proportion of the samples were 0.8%. We follow the European rules, the EN 13292 rule, EN, and made the composite. Finally, we decided to study 5 different percentage of cigarette butts. 0.5%, 1%, 1.5%, 2%, and 2.5%. We count the cigarette butt in weight, like water and gypsum. So we made, this is the picture shows, the slide shows us how we prepare the cigarette butts. First of all, we have to clean them in water, and after, when the cigarette butts are clean, we dry them during 24 hours. The next step is crush them until we have like a sponge, and in this way we can mix the cigarette butts with the gypsum and water. So we made the samples, and this is the kind of samples we made. One of them was for the mechanical behavior, and this, and these are for acoustic behavior. So when we made the test, mechanical test, about about a superficial hardness. That's important if we want to use this gypsum inside of the building, and of course flexural strength and compression strength. We also test bonding, but it was not enough important for us because we always think about gypsum panels with a mechanical joint. But we did it, the test too, because first of all we wanted to be sure that this material was possible to use and have the same behavior than the gypsum, than normal plaster. So as we can see, the density were good, flexural strength too, better than the references without cigarette butt. So our samples improve the normal gypsum. But we realized that the best one was 1.5%. After 1%, the increase is not enough interesting for us. So we decided to choose just one of the percentages and work only in this way. So we test about acoustic, and the difference between reference. This is this is a impedance tube that we try the samples in an impedance tube, and the result was this. We can see there are not enough improvement about absorbent coefficient. So the reference is in orange, is in red, sorry. And as we can see, only in some frequencies are in this X, and this is the coefficient. Only in some frequency we can see an improvement of the reference samples. So our first conclusions were that the addition of cigarette butt improves mechanical behavior. In particular, adding cigarette butts up to 2.5%. But the better results was in 1.5% over the weight of plaster. So no improvements in the blown strength have been observed. That is the main disadvantage found in terms of mechanical property, but it was we was expected that because filter is not a good fixed additive. So it was we expected bonding, it wasn't so good. Regarding the acoustic absorption, the result obtained shows that there are no significant difference between reference. That's because the sound penetration suffers due to the high percentage of gypsum mortar in the samples. This is our next step, because we started to try decrease the quantity of gypsum in the mix, and we did the samples with 0.8 quantity of gypsum, but now we are trying 0.6. That means we are going to save some gypsum, and we are going to stay with the same properties. And these compounds, the final compounds we made, are possible for construction application that don't have to be joined by mechanical join, not but are not to be blended to a ceramic support. So we are working now to find out the minimum amount of gypsum needed to keep or even improve mechanical property. This is one of our challenge. We are almost near, that I say, 0.6% of gypsum, and the other way is to really improve the acoustic behavior, because the filter, the cellulose acetate, is a good absorbent, so we can use it. But we are work about density of these cigarette butts. We can work about this density when we are crushing the cigarette butt. So now we are made like a sponge, and we are trying to not to crush the cigarette butt. We want to cut them and make small pieces of cigarette butt. In this way, between gypsum, we will have small pieces of filter. So this small piece of filter could be good absorbent. Not when we work the cigarette butt like a sponge. And the other big goal is to save gypsum and save and clean the planet. And for me, that's all of I want to tell you today. If you have any question about that,